Hello, my name is Beth Dixon, and this is a recording for a review chapter for Math 1830. We will be covering in this video Chapter 0, Section 6, Factor polynomials completely or identify as not factorable. In our first problem, we have 3x plus 9. In this video, we will be looking at factoring as if you need a quick review of factoring. If you need a complete teaching or reteaching of factoring as if you've never seen it before, there are other videos available. This video is just a quick review. Watch it. If you don't understand everything that's on it, you may want to watch those other videos. You can find those videos by contacting Miss Moneyhun or your instructor, or contacting me, Beth Dixon. Let's look at the first problem that I've already read, which is 3x plus 9. The first thing we always look for in factoring is the common factor. 3x plus 9, they share a 3. 3 divides into both terms. So we'll write the 3 out front, then parentheses to show what's left. So we're going to divide the 3 into both terms. 3 goes into 3x and leaves an x. 3 goes into 9 and leaves a 3. If we wanted to check this problem, and this would just be a check, it's not required work, but is a way to show that how we know that it's the right answer, we would multiply back out 3 times x plus 3. 3 times x gives us back the 3x, and the 3 times 3 gives us back the 9, and the 3x plus 9 matches up. Again, that's the check and is not part of the answer. The answer in factored form is 3 times x plus 3. Next, we have 5x squared plus 3x. In this problem, we have a common factor of an x. They do not share a number common factor because there is no number that goes into 5 and 3 other than 1, and we do not consider 1 a common factor, but they do both contain an x. When we factor out x's, we always want to take the largest that we can, thus the greatest common factor, but we have to choose the lowest in any one term. The 3x cannot give up more than the single x, otherwise it won't be common. So therefore we will factor out the x, and then we would be left in 5x squared. Factoring out 1x, we're left with just 5x to the first. In the 3x, factoring out the x, we would be left with plus 3. This one is pretty easy to check in your head. X times 5x does give us back the 5x squared. X times 3 does give us the plus 3. So we've checked it, and that is the correct factored form, x times 5x plus 3. Our next problem is 6x to the third minus 2x. I always check for numbers first. 6 and 2 have a common factor. 2 divides into both of those numbers. So if 2 divides into both of those numbers, that means 2 is a common factor. Then I check, and I drew the parentheses and realized I hadn't said the x because there is an x that's common. Every term has an x, and the lowest power of x is x to the first, which means that would be the common factor. 2x divides into x to the third and leaves me 3x squared. If I take or divide in to that x, that leaves me excuse me, if I take the 2x and divide it into the 6x to the third, the 2 goes into the 6 and leaves me 3. And the x to the third, taking out 1x, leaves me 2, because we would subtract the exponents when we divide. We keep the subtract sign. 2x goes into 2x. Well, this is like dividing a number by itself. We have to have something there, so we would have to have a 1 to show that that was common. So that would be a 1, and that would be 3x squared minus 1. Has to have a placeholder, because when I multiply it back, 2x times 3x squared gives me the 6x to the third. I would have to have something, in this case the 1. 2x times a negative 1 would give me the negative 2x. Let's look at the next page, and we have x squared minus 1. This is a special product, and you will see a lot of these, and hopefully you'll get really good at factoring these. Notice, first of all, we want to look for a common factor. There is not a common factor. There is no common factor. They do not share a number. They're both ones. And there is not an x common because the 1 does not have an x. Now we look and see that there are two terms. If we're looking at this as a trinomial, which is most of ours that we factor are in that trinomial, notice that it does not have a middle term. There are 0 x's in this problem. So that means that if I had this and used this and multiplied FOIL back out, those middle terms would add to 0. But when I have this, this is called the difference of two squares. And when I multiply this, what I'm going to do is I'm going to have two parentheses, and I'm going to have an x in front and an x in front. What goes in front are the numbers that will multiply to give me my first term. Remember, with FOIL, we multiply first times first. We multiply this times this, and that gives me this first term. Because it gives me that first term here, that means that it gives me x squared. Because I'm going to have an x in the first of each of these parentheses, x times x gives me x squared. That is fixed. The last of these parentheses always gives me this last number here. And to multiply to get -1, I need to think about what multiplies to be -1. Well, there's only one option, 1 times 1. And if I multiply 1 times 1, it needs to be a -1. So the only way to multiply to be a -1 is one of these being negative and one of these being positive. And in that case, watch what happens when I multiply these back out. X times x, which I said was x squared. We picked them to multiply to give me this x squared. Then the outside gives me a positive 1x. I'm going to move these, oops, not that, this, move this down a little bit. On the inside, I get a -1x, and my last term, I get a -1. Look what happens to that last, the inside and the outside of my FOIL. These numbers go to 0. So since those cancel, that leaves me the x squared minus 1 I started with. My first term works, my last term works because I made them work. The middle term works because they divide out and are the same. That they divide out because the 1 and the 1 are identical, except for their signs. One's positive, one's negative, they will add to 0. So for the difference of two squares, I will always get that format. Here is another example of the difference of two squares. 9 is a squared and 4x squared is a squared. How do I know they're squareds? Well, squared numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, That's 12. 13 is 169. 14 is 196. 15 is 225, and it keeps going. We'll put 3 dots out there. How did I know those? Well, if you hadn't figured out the pattern, 1 squared is 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. I'll leave you to see that the rest of those are true. So those are all your squares. So 9 and 4 are on the list, and x squared, of course, is a squared because x times x would give you x squared. So how do we factor this? Well, we put our 2 parentheses, and then we put 9. Well, 9 would be 3 times 3. 4 would be 2x times 2x. And they have to be identical except for the signs. Because it's a minus, I need a minus and a plus. The first terms work, 3 times 3, which would be 9. The last terms work because negative 2x and a positive 2x would give me a negative 4x squared. What we're really looking for then is do the outside and the inside terms make, I didn't mean to do that. Well, come on. Okay, so let me back up. I had to move that down and it didn't want to group. I thought it was one group. So now we have 9 and the minus 4x squared. What we're really interested in is does this outside and this inside, do they make the same numbers but divide out? Or subtract out, not divide out, subtract out. 3 times 2 is a positive 6x. Negative 2x times 3 is a negative 6x. So they do subtract out and leave me 9 minus 4x squared. So that does work. So what is my answer? My answer is 2. No, my answer is not 2. My answer is 3 minus 2x times 3 plus 2x. And so that would be my answer. And because of that, I can factor the difference of 2 squares relatively quickly. Let's look at the next problem, which is 6x squared minus 24. In the previous problem, I actually did it in my head, but didn't say it out loud. I did look for a common factor. This problem does have a common factor of a 6. And I'm going to work it down here below and then write the answer over to the side, but I'm going to factor out that 6 before I do anything else. 6 goes into 6x squared and leaves me x squared. 6 goes into 24 and leaves me 4. That then leaves me 6 times x squared minus 4. Well, the x squared minus 4 has 2 terms, and it happens to be the difference of 2 squares. So I will leave the 6. It comes straight down and is part of my answer, but does not need to be changed in any way. Just comes down. Then I will draw my 2 parentheses. Then I have my x and my x. What multiplies to give you 4 would be 2 and 2, and one of them needs to be a minus and the other one needs to be a positive. The order that I write the minus and the positive does not matter. It can be written in either order. So what will we do next? Well, that's the answer. 6 times x minus 2 times x plus 2. But if I wanted to check it, I could multiply it back out. 6 times x is x squared. Outside would be positive 2x, inside would be minus 2x, negative 2 times positive 2 is a negative 4. The positive 2x and the negative 2x add to 0. 6x squared minus 4. 6 times x squared is 6x squared. 6 times a negative 4 is a minus 24, and that matches up to the original. Just remember that all of this is your check. This is your answer. Now let's look at our next problem, which is 5x to the third minus 45x. Common factor would not only be the 5, which goes into both 5 and 45, but also the x. So I write the common factor. What's left when I divide out 5x from 5x to the third is x squared. What's left when I divide 5x into 45x would be a minus 9. And I'm always careful to check at this point before I proceed. 5x times x squared gives me back 5x to the third. 5x times 9 gives me back 45x. Then the x squared minus 9 needs to be checked to see if it can be factored more. In this case, it is also the difference of two squares. It is a difference. It is both of those are squareds. Remember, this does have to have a negative at the minus 9. It does not work if it is a plus 9. And here's why. When I draw the parentheses and I have an x and an x in the first of the parentheses, to get the 9, the 3 and the 3 work, they have to be the same number, but they have to be opposite signs so that the middle terms cancel to give me 0. So that makes one of them a positive and one of them a negative. A positive 3 times a negative 3, a positive 3 times a negative 3, give me a negative 9. So this up here has to be a negative 9 for this to be the difference of two squares. That's why we don't say the sum of two squares or just two squares. It only works if they are the difference of two squares. So this would be our answer. That would be 5x times x plus 3 times x minus 3. Notice this time I wrote the plus first. I have no set way of writing it. It just comes out. Sometimes the plus is written first, sometimes the minus is written first. So let's check this to be sure that it works. X times x is x squared plus 3x minus 3x minus 9. Notice I didn't do FOIL. I did FIOL. That's because when I was in school, I couldn't spell FOIL, and I often did FIOL. And so sometimes I go back and do it that way. It's just something that happens every once in a while. I'm not going to go back and change it, and definitely not go back and re-record this to fix that error. I caught it rather quickly, but you need to do FOIL so that you don't get confused. Then your signs would be reversed, but they still cancel either way. So you get x squared minus 9. 5x times x squared would be 5x to the third. 5x times negative 9 would be minus 45x. And since this matches this, we can put a big check that that is our correct answer. Now we're on to trinomials. Trinomials means there's three parts. So our middle part does not disappear or cancel out anymore. We have to work and get an actual number. But our process is pretty much the same. First, we look for a greatest common factor. They don't share a number. 1, 3, and 2 don't have a common factor. And they don't share an x. Excuse me a minute, I need to get a sip of my tea. And they don't share a common factor. So what do they need? Well, when I draw my parentheses here, I'll have two parentheses. And to get that x squared, I still need an x and an x. So how do I get a 2 at the end and a 3x in the middle? Well, you want to start not at the middle, but at the end. We multiply to get the last term and add to get the middle term. So the last term is a positive 2. So if that last term is a positive 2, the only things that multiply to give you 2 are 1 times 2. So I know that here is going to be a 1 and a 2. And then we have a set of rules that will help you determine what to do next. And they have to do with the sign of the last term. And again, we start with the last term, not the middle term. Look to the last term. If the last term is positive, if the last term is positive, then the factors will both match the middle term. If the last term is positive, then the factors will both match the middle term. In other words, if this last term here is positive, the signs in these answers, which are the factors, will both be the same as that middle term, in this case, a positive. So if that last term is positive, they'll both have the same sign as that middle. In our case, that's both positives. Now, why is that so? Well, we know that the answer is going to be x plus 1 times x plus 2, or this does not factor. Why? Because the only possible answer I have to multiply to get 2 is 1 times 2. However, let's look and see how that works when I use FOIL to check this. X times x is x squared. That's the first. I know that works because I picked it to work. I also know that 1 times 2 gives me 2 because I chose that from a list of numbers that multiplied to give me 2. I don't have to really worry about the first and the last. What I'm worried about is that outer and inner that make up the outer, well, let's write it this way, the outer plus the inner that make up that middle term. So what does that give me? Well, the outer gives me 1x times 2x, which is plus 2x. 1x times x, 1 times x gives me 1x. So I have 1x plus 2x. Well, 1 plus 2 gives me 3, so I know it's going to work. So that gives me x squared plus 3x. They both have to be positive because I need a positive 3x. So both the 2x and the 1x both need to be positive so that when I add, I get a positive 3x. So the answer to x squared plus 3x plus 2 factored is x plus 1, x plus 2. Next, we have 3x squared minus 18x plus 15. The first thing we should see is that we have a common factor of 3. 3 goes into 3, 3 goes into 18, and 3 goes into 15. So I'm going to factor out a 3. Notice we do not have a common factor of x. There's not an x that's common all the way through. Now, watch me write that number down wrong. So 3 goes into itself and leaves 1. 3 goes into 18 and leaves 6. And 3 goes into 15 and leaves 5. So that leaves us 3 times x squared minus 6x plus 5. So we'll leave the 3 where it's at. it will not change. But the x squared minus 6x plus 5 needs to be looked at to see if it can factor some more. Remember, our directions say factor completely. So with x squared, we're going to put an x in front of both parentheses, and then we're going to look at that last term, and that last term is a positive 5. Remember that our goal is to multiply to be 5. The only things that multiply to be 5 are 1 and 5. If we multiply to be 5, that gives us 1 times 5 is 5. Do they add to be 6? Well, 1 and 5 do give me 6 when I add, and they need to be the same sign as that middle term. Our middle term is a negative. Our middle term is a negative. So these need to be a -1 and a -5. Does -1 times -5 give me a positive 5? Well, a negative times a negative gives me a positive. 1 times 5 is 5. So yes, so a -1 and a -5 multiplied to give me a positive 5. And if I check it, and again, I'm just going to check the outside and the inside, which would be -5x and -1x, that gives me the -6x as my middle term. I can look at it and see x times x gives me the x squared, and -1 times a -5 to give me my positive 5. It's those inside and outside that works together that I really need to write down to check. So what is my final answer? Well, my final answer has to contain the 3, and then it's the x minus 1 times the x minus 5. My next problem is 2x to the third plus 6x squared minus 20x. This one has a 2 that's common as well as an x that's common. 2x goes into 2x to the third and leaves me x squared. 2x goes into 6x squared and gives me 3x, and 2x goes into 20x and leaves me 10. So I have 2x times x squared plus 3x minus 10. So I'm going to bring down the 2x, draw the 2 parentheses for the x squared plus 3x minus 10. Notice my last term this time is a -10. This is the first time we have a negative. Now, what are the rules if the last term is negative? Notice our rule was if the last term was positive. So if my last term is negative, if my last term is negative, then the factors if my last term is negative, then the factors will have 1 positive and 1 negative. If the last term is positive, if the last term is negative, then the factors will have 1 positive and 1 negative factor. In other words, to get a -10, we can have one of 2 number combinations. We can have 1 times 10 or 2 times 5. Those are the numbers. But to get a -10, one has to be positive and the other one has to be negative. And to be a positive and a negative, then we have to, yes, I noticed positive was misspelled. So let me fix my spelling there. I never claimed to be a spelling master. Okay, so I have to fix the signs, okay? So one will have to be positive and one will have to be negative. And and I keep losing the words there. So then the factors, just erased the whole side there. So my factors will have to be one of each. I can multiply a positive 2 and a negative 5 and a negative 1 and a positive 10, but they both can't be negative or they both can't be positive because that will not give me a negative 10. To be a negative, I need one positive and one negative in those factors. And instead of adding to get my middle term, I need to subtract to get my middle term. Because the signs are different, when I add, I will be subtracting. So my signs will be different when my last term is negative, and I will be subtracting. Now notice I subtract to get 3. I do not subtract to get this 6x squared. This is gone. This is what my final answer is, but this right here is what I'm factoring. I am factoring x squared plus 3x minus 10. It's that 3 I need. So 5 minus 2 gives me 3. So I know that to get the x squared, I need x and x. To get the 3, I know 10 and 1 give me 9, but 5 and 2 would give me 3. So I need the 5 and the 2. Now, the question is, I need a positive 3. To get a positive 3, I need the 5 to be positive and the 2 to be negative. The larger of the two terms needs to match the middle. Positive 5, take away 2 gives me a positive 3. So I need the 2 to be negative and the 5 to be positive. Now the order in which I write these does not matter, but in this case the 5 has to remain positive. If the 5 is negative, I will end up with a negative 3x. Let's multiply this out to show you how that works. X times x is x squared. Well, I'm not even going to multiply the outside and the inside terms. I'm just going to, excuse me, the first and last terms. I'm just going to multiply the outside and the inside. Outside would be plus 5x. Inside is a minus 2x. A negative 2 and a positive 5 gives me a positive 3x, which matches. X times x is x squared. Negative 2 times negative 5 is negative 10. Actually, I did do it, but I did it a little bit different order because I know the first and last terms work. Then it gets multiplied by 2x. 2x times x squared would be 2x to the third. 2x times 6x would be plus 6x squared. 2x times negative 10 would be negative 20x. And this matches this. And so that is the correct answer. But where is the answer? Well, right there is the answer because that is in factored form. 2x, x minus 2, x plus 5 is the factored form. This part right here, I've started multiplying back, and therefore that is the check. Next, we have x squared minus 6. There is not a common factor, and 6 is not a perfect square. So this is not factorable. If I write in parentheses x and x, and the only things that multiply to be 6 are 1 and 6 and 2 and 3. 2 and 3 look like they would work. Okay, but if I do that, what do I get? I get a minus 2x and a positive 3x, and they do not cancel. They leave me a positive 1x, which does not match. And therefore, it is not factorable. It has to be the difference of two squareds. The last set of problems that we will do here are the most difficult because they involve numbers other than 1x squared. So not only do we have to look at what multiplies to give me my last term, we have to also think about what multiplies to give me my first term. 3x squared plus 11x plus 6. There are no common factors, so when we draw our two parentheses, we have to get at first term, there's our first term, and it's got to be a 3x squared. Our last term has got to be a positive 6. So we know the 6 is 1 and 6 or 2 and 3. So when I put that 3x squared, I know the only way to multiply to get 3 is 1 and 3. So I'm going to go x and 3x. That's the only way I can multiply to get 3. The question is, how do that 1 and 6 work with the 1 and 3, or how do the 2 and 3 work with the 1 and 3 to create an 11? I know that 1 and 6 gives me 7, 2 and 3 gives me 5. Neither one of them give me an 11, but that doesn't take into account the 1 and the 3 that are already up here. So let's start first by understanding that where they're placed is going to be important. So 1 and 6 will be different than 6 and 1, and 2 and 3 will be 2 and 3 will be different than 3 and 2. So I will write these in opposite order so that I can remember to check everything. Then I'm going to tell you a secret. Math teachers are predictable. And when math teachers are predictable, we tend to make our answers of numbers that are closer together than they are further apart when we factor. And by that, I mean 2 and 3 are closer on the number line than 1 and 6. So more often than not, the answers are going to be 2 and 3 than they are going to be 1 and 6. It doesn't mean 1 and 6 won't be the answers. It just means 2 and 3 are more likely to be the answers. So play the odds. Choose 2 and 3 and 3 and 2 before you choose the 1 and 6. And most of the time you choose the right guess as your check, as your answer. This is called the trial and error method because you try it. If it gives you an error, you go back and guess and check something else. Sometimes it's called the guess and check. So I'm going to choose the 3 and the 2 first. As I look at this, what I'm going to do is remember my sign rules. That last term is positive, so both will be the same as that middle term. So I know both of these are going to be positive. I'm going to put I'm going to choose not the 3 and the 2. I'm going to choose the 2 and the 3 first. And so I'm going to put the 2 here and the 3 here. And so what I'm going to do is I want to choose that. And as I multiply that out, remember that the x times 3x works because I picked it from that first list. The 2 times 3 works because I picked it from the list that gives me 6. So again, it's that outside and inside that I need to work together. So as I look at that outside and the inside, this is the outside, there's your outside, and this is your inside. So that's the 2 I'm working with. So I get 6x and 3x, which gives me 9x. And that does not work. So what I'm going to do is just erase that. And that's what you will do. You will erase it or you will rewrite it. If I could have made it, well, I could have made it smaller. I figured out how to do that today. But what I'm going to do then is change the colors. And instead of 2 and 3, I'm going to choose the 3 and the 2. And the reason why I changed which ones I was going to try first is because I want to show you what happens when you choose the wrong answer. So let's put a 3 and a 2, and the outside then would be these two, the inside would be these two. And so the inside would be 9x, the outside would be 2x, and 9x plus 2x would be 11x, and that matches. So our answer would be x plus 3 times 3x plus 2. Again, x times 3x would be 3x squared. X times 2 would be 2x. 3x times 3x would be 9x. 3 times 2 would be plus 6. The 2 together make 11x plus the 6, and that gives you the original answer, so that does check out. And that's how you do it. You may need more practice because factoring is one of the harder skills that we do. So the practice from the textbook is page 37, problem 1, 7 through 16, 19 through 33, 53, and 55. If you do need to get in touch with me, you can reach me on the Morristown campus in room 222, or you can email me at beth.dixon@ws.edu. And again, I'm on the Morristown campus in the Math and Behavioral Social Science building, room 222. Thank you for watching.